believe you.
Test, test. All right, welcome back, everybody. Today, we will be gaining some more practice with references and lists. Today is primarily a practice-based lecture. We're going to be working through 3 different diagrams, and I've heard the feedback that you all wanted more challenging diagrams in class, so I think today's are pretty challenging, and we'll prepare you for the quiz that's coming up. Couple of quick announcements before we get into it. If you are considering minoring or majoring in computer science, or are definitely minoring or majoring, tonight we're hosting a panel of undergraduate teaching assistants and talking about what I wish I knew when I was in COMP110. This is something we've done, it's been since COVID, since we've done one of these, but prior to COVID, this was a very valuable and warm event for you to learn a little bit more about what's going on in computer science, ask some of the questions, concerns that might be in your head. and just meet some other UTAs and hear about their experiences. This is tonight in Citizen 014 at 7 p.m. I would highly encourage joining. The next exercise will go out, and it's a continuation of working with lists. It will involve unit tests like we saw on Tuesday. And then the quiz that's coming up on Tuesday will be primarily about the types of things we're doing in class today and have been looking at for the past couple weeks. So an emphasis is on lists and reference types and passing references around, which we'll get a lot of practice with today, as well as scopes, which you all encountered on the project, where you have global scopes versus local scopes, and we'll dig into that today. The projects are currently being graded by the UTAs. We're enjoying moving through the creative choose your own adventures that you all put together, and hoping to get those out sometime next week so that you all have those grades going into the quiz. So today we will be doing practice diagrams. I would encourage having paper out and a pen or pencil, and we're going to jump right into it because I want a lot of time to be able to discuss questions that come up on these problems. So this first challenge question is looks pretty simple, right? We've got two function definitions and some global variables being defined. And then we've got a keyword that you all saw in the most recent project, right? This global keyword is something that you'll need to navigate in the diagram that basically means in the context of this G function, Y is going to refer to the global Y, not a local Y within the frame for G when you get to that point. The other thing that you're going to need to be careful of, just to give you a quick heads up, is in this G function, notice that the F function is being called twice. We'll talk through this when we work through it together, but what you should know is when the same function gets called twice, you're going to have two frames for it on your stack. All right? So just like you set up one frame, you're going to set up another frame. Both of them will be labeled F, and that's totally fine. All right, with those warnings out of the way, I actually want to turn it over to you all to work through this, and feel free to work with your neighbors, and we'll check back in about 10 minutes. 2 more minutes on this one, 2 more minutes. We'll talk about it together. One more minute. All right. Let's bring it back and talk through this. So there's, a lot of X's and Y's in this particular code listing. And part of what we're looking at and emphasizing in this example is the idea of scopes. And the idea of scope is from some part of our program when we refer to some name such as X or Y, which X or Y are we actually referring to and can we access it? So I've gone ahead and set up the starting point here that gets us down to line 18. And hopefully there's nothing surprising on what we've got so far. I've set up my X and Y variables. Notice that because I declared these outside of any function definition, these are variables that exist in global memory, and we would refer to them as global variables. And that'll come back to be important when we get into this G function. So we call G on line 18, and it's a pretty straightforward function call. The return address is line 18. There are no parameters to set up, and we're ready to jump straight in. As soon as we get into this G function, we see this global Y statement that you all saw for the very first time when you were working on the project very recently. And what this is saying is, from within this context or within this function definition and evaluating this function body, so this is our current frame, from within this point, if we refer to Y and we try and reassign Y, we're actually going to be reassigning the global Y. Now, we haven't done that yet. We're just making a note of it. In other words, we're never going to have a Y that's local inside of this G frame, right? We're never going to declare a Y inside of this G frame because we're saying, no, Y in this function is referring to the global Y and not one that would be locally declared. We can contrast that with X, which is being declared as a local variable. Now, technically, we should go figure out what f of 3 is, and we'll do that in just a second. But if you wanted to, you could go ahead and carve out some space for x to say that, oh, yeah, we're declaring a local variable x in the frame for G. And that's different from what we're saying how Y is going to work within this frame. Y is going to refer to this global Y. All right? So let's go and figure out this function call here and figure out what is the return value so that we know what to initialize x to. Well, we ask, have we seen something named f? So we look in our current frame. There's nothing named f there. So we look in globals. Yes, it's the function definition we see right up here. No worries. We see that our argument 3 corresponds to the parameter x. Both are floats. That checks out. And we can also see that this function is going to return or result in a floating point value, which is OK because we're trying to assign it to a variable that can store a floating point value. So the return type matches up as well. So this is a valid function call. We can set up a frame for it. And in doing so, we set up f with the return address of line 12. And we need to pass in this argument. So 3 is going to be assigned to x. And x is going to be set up as a parameter, which is also a local variable inside of this frame for f. All right? So we've established this frame. And we are now on line 5. We see the addition reassignment operator where we're saying take the current value of x, which is 3, increase it by 1. So I'm just going to cross this out and say it's 4.0 and reassign it back to itself. All right? So this, you will see this operator moving forward in the course. So we should be comfortable with it. And as just a quick reminder, you can also have minus equals for subtracting what's on the right-hand side by the current values, the current variable. We're just changing x relative to its current value, right? Once again, we see a declaration for y, but in this case, this is actually different than what we saw in G. So notice we're declaring a variable named y. We're not saying global y within f. And so y is going to be established as the value of x, which is in our current frame, 4.0. 4.0 plus 2.0 is going to be 6.0, right? And notice that we do have a y in the f frame for this function call because we're declaring it locally. And it's very important to be able to distinguish between a local variable declaration, meaning we're declaring it within the context of a function, and a global variable declaration, which means we declare these variables outside. And then in G, we saw, yeah, you can say that, okay, we're going to have y be global rather than local to this function. And the idea of local versus global is, again, local means inside of a function frame. Global means in the global's frame, all right? So we reach line 7, which is a return statement. We need to figure out what is x plus y. So we look in our current frame. And as a reminder, and you're going to get really sick of me hearing me say this, our current frame is the lowest frame on the stack that is yet to return. So it's going to be this one. There's no return value in this frame for f. So we look up in this frame, all right, what's x? X is 4.0 plus y, which is 6.0. So that's going to be 10.0 as our return value. And where are we sending 10.0? We're sending it back to line 12. All right, so this is going back to line 12, which is where this function call occurred. So f of 3.0 returned in a value of 10.0, all right? So that means that we're taking 10.0 as the result of this evaluation. But now our current frame is back in the G frame, right? Because this F frame has returned. It's completed all the work that it needs to do. I might just circle around that. Doesn't matter. I'll keep doing it the way that we've done it most of the semester. 4 is still associated with x here. So here we're saying in line 12, initialize x to be what that function call evaluated to. That's 10.0. All right. Before I move on to line 13, let me pause here and see if we have any questions. So the next thing we're going to do is line 13. We have not done that yet. But any questions on what we've seen so far? All right, so where this starts to get more interesting and novel relative to what we've seen earlier in the semester is on this call. So I imagine there will be some questions after we evaluate this. Here we're saying assign to y in our current frame, which is G, but remember, we declared y to be global, so ultimately we're going to be impacting the global y. But we need to go figure out what is f of x plus 4.0, right? So when we reach a function call like this, we first need to evaluate the arguments, and we're asking, okay, what is f of x is 10, so 10 plus 4 is going to be 14.0. So this is the same as asking what is f of 14.0. And we know that this is a valid function called a f, right? F takes a single float parameter. We've got a single float argument, and we're assigning it to y, and y in globals is a floating value, so we're using it correctly. So here's where we need to do something special. We need to set up a new frame, right? So I actually shouldn't call this special. It's actually what we've been doing this whole time. But notice this f frame is going to have a different return address. This function call occurred on line 13, so the return address of this call to the f function is line 13. And the x parameter that we need to establish is going to be 14.0. All right? Awesome. So we've got 14 for x. We've got our parameter established. We've got our return address written down. We're ready to jump in. So we're evaluating f for the second time in this program. That's fine. You can call functions more than once. And most programs do call functions more than once. So x is going to increase by 1. X is no longer 14. It's now going to be 15. We establish y in this frame. So we're once again declaring a variable named y, local to this frame that we're evaluating currently. So our current frame is now this one. It's the lowest that hasn't returned. And that's x, which is 15 plus 2, so 17.0. And then we reach this return statement one more time. So what is x plus y? Our current frame is the frame where x is 15 and y is 17. So we substitute those in, and we're going to have a return value of 32.0, 15 plus 17. All right, so our return value here is 32.0 because it's a float. And we're sending that back to line 13, right? So f of x plus 4.0 evaluated to 32. And here's where we need to be careful. We're saying this function call resulted in a value of 32.0, and now we need to assign it to y. Well, remember, there is no y, so we're done with this frame for f, right? We've completed this frame. It's got a return value. Our current frame, we're back working on g, and there is no y in this frame, right? And that's because we declared y to be working with the global y, right? So when we assign to y, we're not going to assign to a y inside of g's frame. We're going to change the global value of y to be 32.0. Right? And so the idea of this global keyword in Python is that it gives us the ability to say, hey, when I assign to a value, or a variable, in this case named y, change the global variable, not something that's local inside of this function frame. Okay? So that completes line 13. And let me pause right here, because that's really the bread and butter of this. There's not much left to do in this one before we finish it up. We're not quite done yet, but any questions on what we're seeing here? Yep, we got a question here coming around with a mic. Just 1 second.
Are we allowed to write global y in the G frame just to note that there is a y there that we're interacting with in that frame, even though it's not an actual variable?
That's a great question, and I love it. I'm happy to have you write, if it'll help you write global y here or something like that. We won't be looking for that or grading for that, but to help you remember it, that's totally fine. Yep, good question. Other questions? We got one up front here, coming with the mic. Just 1 sec. The mic's useful because in the recording, you can actually hear the questions, and the people who are watching from home can hear as well.
If we have like different mentions of y in like a definition of a function, like do we have to write global every time, or just like once would suffice?
So I think the question, and let me see if I can rephrase your question and correct me if I'm misinterpreting, is if we're not reassigning to y, so this is what, like you only need to say something's a global variable if you want to be able to change that global variable from within a function definition. So if you were to actually have, like if I were not to have had this line here, right? And we called f of x, and we tried to access y from this point, we would have still been able to read the global variable y, but we couldn't change the global variable y without having global y specified. And the reason is, if you don't specify global y here, Python will think, oh, I'm trying to do this to a local variable, and in this case, we wouldn't have declared it yet, and that'll potentially lead into trouble. But anytime you declare a variable like this, that will set it up as a local. Is that close enough to what you're asking, or do you want to clarify?
Yeah, I was asking if like there was another y, so like let's say like within G, right?
Okay,
Like
yep.
there was like another like other lines, and then like it says y again. So
Sure.
that global y, the first one, would it like refer to both y's, or like do you have to like restate that it's global y again?
Got it. Good question. So the question is, does this only apply? So we used this once. We declared this to be global y here, and then we used it once here. What happens if we said y is assigned 10.0 down here? They will all refer to the global y in this case. And one other thing I want to point out is that if you did attempt to say global y, it will prevent you from like declaring a local variable y. So I couldn't say y is float. That's 10.0. We would see that like, hey, you were trying to use the global variable y within this function. You can't redeclare a local variable y because it doesn't really make sense. So you kind of are going one way or the other. Good question. Got a question over here on the left. While we're waiting for that question, I'm just going to bring this home real quick. So we left off right here on line 13. We just finished evaluating line 13. We've reached the end of a function that returns none, or a procedure. And remember, that means there's this sort of implicit return none here. So what we would do in our diagram is in this frame for G, our current frame, the return value would be none. And then we would return back to line 18. Well, there's nothing that comes after line 18. So our program has completed. And we got a question over here.
So could you make a local Y, like before you declared a global Y? Like after it you couldn't, but before could you?
Good question. Could you declare a local Y before a global Y? Typically, my answer would be no. I'm actually not certain whether you can or not. You can try it, but I'm going to encourage you to believe that you can't because it would be pretty confusing. If you want to do something like that, I would encourage using a different variable name for the local one versus the global one. And typically, it would be really uncommon that you would really need to use the same variable name for both. So here, you know, these examples are pretty contrived. So like that we're clashing on X and Y as like names of all of our variables in this example is pretty uncommon. When you're writing your own programs, choosing variable names that aren't going to conflict with one another is encouraged. Good question. All right. Let's move to the next question. And this one is involving a list with some references. Once again, I'll give you all a few minutes here to work through this, and then we'll come back and work through it together. One note I will make is that all of these slides are on the course homepage. So if you want these code listings to have at home, just look for the slide deck that's listed under today's lecture materials. And it's a PDF, so you can write on it if you need to, and it should be there for you. One other quick reminder I will make is you can assume that this if statement, this equality comparison evaluates to true in this code listing, but we'll talk about that again when we get there. One more minute on this, and we'll work through it together. Twenty more seconds, and we'll talk through this one together. All right. I know some of you are still working on this one. Totally fine. I just want to be sure that we're able to get through all three questions today. So I've gone ahead and fast forwarded to the point of the main function being called. We've got our two definitions, and then here we see this Python idiom, which is saying if the name of the module that we're evaluating is equal to main. And this is kind of a weird thing, but when you run your program using the like Python -m and then whatever syntax, behind the scenes, when Python begins this program, there's a special built-in variable named __name__ that will be assigned main. And you're probably thinking, why does this matter? When would it ever not be main? Well, we just saw a video on unit tests where you imported functions from one file to another. And if we were to have, like, say, written some tests and imported move back into our test file, then when Python goes to evaluate this, name would not have been main, such that we could have just imported that function without our whole program in this file running and without our main function running. We don't really need to get lost in those details right now. I just want to say that for our purposes, if we ask you to trace a diagram, we will tell you that the name is main, and we would never ask you to trace a program that isn't true. But in the real world, there is a good reason for this existing. And as our programs get larger and are made of multiple files, and we're importing functions and other things from one place to another, it becomes more important when we get there. On line 5, we establish a list variable and associate it with a reference to this list literal, which constructs an object on the heap. So whenever you see a list literal, which you know with these square brackets and then the values inside of it, it's a list literal where we have 4 string values, T, G, D, H, respectively. And when you establish that on the heap, it evaluates to a reference to it. So when we say message is assigned this list, message isn't actually that list, it's a reference to that list, which will become important when we think about this function call on line 6. So we're ready to evaluate line 6. We see a function called a move back. We ask, have we seen that definition? Yep, it's this function down here. And we see that we have our first argument, message, is being assigned to x's, this list of strings. Well, message is also a list of strings, so this checks out. We see the second argument is being assigned to the second parameter index. Both are integers, so that checks out. And this is a function that returns none. Well, we're not trying to do anything with this resulting, like we're not trying to assign the result of this function to anything or print it or anything, so totally fine. So let's set up this frame on the stack. So we're going to set up a frame for move back. And we're going to have a return address of line 6. And then we need to set up our parameters, x's and index. All right. Now, I want to be careful with x's and highlight it specially because this is what's really important about this example. Notice on line 6, we're saying take whatever message is in main. So in the main frame, what message is it's this reference right here, right, that I'm highlighting in purple. And we're saying take that reference and assign that same reference to x's. So x's is going to be that same reference to this list. So now x's and message both refer to the exact same list object on the heap. And that works a little differently than our second argument here, which is the number integer 0. So integer 0 will be assigned to index, and we copy that value in, no worries. Okay? So we've established this frame, and we're ready to jump in. The first thing that we see is a local variable being declared. And we have to ask ourselves, what is x's of index? Well, index is 0, right? So what is x's of 0 is what this line is evaluating to. So x's of 0, we look up in the x's list. Index 0 is the string t. So what we're saying is assign t to a variable named temp, right? So I'm going to set up my variable named temp, and it's the string t. Okay? On the next line, we see a pair of other assignment statements, right? So here, we first need to figure out what's the right-hand side. Well, index is 0, so 0 plus 1 is going to be 1. So what is the evaluation of x's at index 1? Well, we look up x's is this list. Index 1 is the string g, right? So we're saying take g and assign it to x's of index, right? So let me just write this out so that we know what we're evaluating here. So x's of index is assigned g. Well, index is 0, right? So we're asking we're asking the program to assign to index 0 of x's the string g. Right? So we can do this. We say, okay, x is index 0. That's currently t, but we're going to replace that with the string g. All right? So we're changing the value at index 0 to be the string g. And we've completed line 13. On line 14, we're doing something very similar, but this time around, we're saying, okay, take this temp variable that we set up, which is local, and that's the string t, and assign it to x's of index plus 1, so index is 0. This is saying x's of 1 should be assigned the string t. That's what line 14 simplifies to. So we say, okay, we look in our list, and we replace index 1 with the string t. All right. We reach the end of this function definition. So this is a function that returns none. The return value is none. And we return back to the main function. And I want to pause here. We're about to evaluate line 7. But let me pause here and see if there are questions on what we've done so far. Got a question over here. Coming around with a mic to Tyler.
I still really don't understand why x of s wouldn't just be like the index 1 and then like temp would be like the previous g. Do you get what I'm saying? Like,
can you, which line specifically?
Like 13 and 14 is where I'm like confused.
Okay. Yeah, let's look at line 14 and break that down one more time real quickly. So line 14, I'm going to revert my diagram back to before this line was evaluated. All right, so our state in memory is this. We have temp has a value of t, index has a value of 0. And now what we're trying to evaluate is the assignment statement, x's of index plus 1 is assigned temp. All right. Typically, when you see an assignment statement like this, you really want to focus on the right-hand side first. So this simplifies to the same thing on the right-hand side is assigned temp, which is the string t. Right? And let's focus on the left-hand side now. So on the left-hand side, x's of index plus 1. Well, index is currently 0, right? So 0 plus 1 is going to evaluate to 1, is assigned the string t. And here's where we're saying, okay, we want to update this x's list at index 1 to be t. Currently, index 1 is the string g, so we're replacing it with the string t at index 1. Right? And what we did in the previous line was something kind of similar, but on the previous line we're saying, this is actually saying, look in the index after me. So our index is 0. On the right-hand side, index plus 1 is 1. So look at index 1 and assign whatever was at index 1 to index 0. It was like we were copying it. And the effect of this, if we want to think about what's going on at a high level, is notice that before we replace these, T was at index 0, it's now at index 1, and G was at index 1, it's now at index 0. So this move back function is effectively saying you give it an index, and whatever item is at that index, it's moving it back by one position, and whatever was there, it's being moved forward by one position. We're swapping these two indices in essence. Does that help? Good. Other questions? All right, so we've got one more of these functions to carry through. So let's go ahead and work through that, and we can slow down on the line 13 when we get there as well. So I'm just going to clear out my scratch here. So we're now on line 7, and we want to evaluate this. Well, we set up another frame for move back. The return address this time is line 7, right? So we've moved forward by one line. And we need to set up our parameters. So our parameters for this function are x's and index. All right? So let's be careful about how we set up these parameters. We're in the current frame of evaluation is main. We're saying take whatever message is. Well, message is this reference to this list. So we're going to copy that reference. So now x's in this next frame is also going to be a reference to that list. And index is going to be whatever the second argument is. Well, that's the number 2, so index is going to be 2 for this function call. Right? So we can already see there's a difference in the state of these two function calls as we set these frames up. X's is the same, but our return address is different because the function call occurred on a separate line. And our index is different because we chose, these are two different arguments that we're calling this function with. Right? So we jump in and we set up this temp variable, and temp is going to be whatever is at x's of index. Well, we look in our current frame where index is 2, that has the string of D. And then we reach line 13. And this time around, I'm going to do what I did previously, where I'm going to write this whole line out and think about it step by step. So this is x's of index is assigned x's of index plus 1. All right. So this is line 13. And if we think about this step by step, you always want to focus, when you see an assignment statement, on the right-hand side first. And here we can kind of work our way out. Index is 2. So 2 plus 1 is 3, so this is going to be x's of index 3 is being assigned to x's of index. And I might go ahead and substitute index here. So notice that x's of index is saying x's of 2, right? Because that's our current index value in the frame that we're working in. All right? And so now we're saying, OK, look up what is x's at index 3. Well, that's the string h. String h is being assigned to x's of index 2. And so what are we doing? Well, we're saying, OK, in x's, replace this current value, d, with the string h. Right? And notice we've kind of copied the index 3 into 2, and now we have 2 h's in our list. But we really wanted to shift that d that was there back. D is stored in our temporary variable, and so that's what's happening on line 14. Right? So on line 14, we see that temp, which has a value of d, is being assigned to x's of index plus 1. Our index is 2, so x's of 3, index plus 1, is assigned the string d, is what this evaluates to. And so now this index, 3, is replaced with the string d. All right? And so notice we moved what was at index 2 back and at index 3 forward, in a sense. That's what this move back function was ultimately doing. And we reach the end of this procedure, so we return none. That brings us back to line 7. We've just completed line 7. When we print message, we have to ask ourselves, what is message? Well, we're back in the main frame. Both move back frames have returned. And our message, when we print out a list, we use list literal syntax. So the output of this one would be the list literal, open square bracket, string G, string T, string H, string D. Just a random assortment of letters. And we reach the end of this main function. Our return value is none, so we return none, and our program listing has completed. So after that second pass through, any questions on what we're seeing here with these list indices? So this example is showing you how you can reassign individual items in a list using the assignment operator. And here we're shifting letters around. So effectively what this example did was it moved T back by 1 and D back by 1, H forward by 1, and G forward by 1, right? All right. Let's move on to the last one. This one's long, but it actually, I think, is shorter to ultimately process than the previous question, because there's only one function call involved. But we are calling a function with two lists. So go ahead and get a start on this, and we'll come back and work through this in another 6 or 7 minutes or so. going to go ahead and switch to a slide and start setting up these two lists. Apologize, the size of this text is pretty small, but if you pull up the slide on your course webpage, you can also see it there. But I'm going to go ahead and get this set up. All right. For the purposes of being sure we're able to work through this and take questions, I think it's going to make most sense to go ahead and get started on tracing through this together. And then I'm going to give you a couple of variations on this you can try and work through at home. One of the things that I will encourage is, in preparation for a quiz, trying to go back and reproduce these diagrams without any help, without watching the video, without looking at what you did before, and convincing yourself that you're able to, same with the lecture that came a week ago, is what I would encourage as a very valuable practice. In addition to, tomorrow we'll have practice questions available on the website as well, and we'll list those in the itinerary and on the resources page. So here, I've got my list set up. X's is associated with the list 1, 3, 3, 4, 5. Y is with the list 1, 2, 3. And then we want to call this function differences, right? So here's where you got to be careful. Differences is this function definition. We see that we're trying to call it with an argument of x's, which x's type is list of integers. That corresponds with the a parameters list of integers type. Y's is also a list of integers. That corresponds with the parameter b's type, so that checks out. And this returns an int, so ultimately we are going to print out some integer value, and we know that, right? But let's go ahead and set up this frame. So differences is going to return back to line 26 in that print statement. And we have two parameters we need to set up, a and b. And here's where you want to be very careful, right? So what we're saying is take x's in the globals frame. I'm going to highlight this in a special color. I'm going to use purple again. X's, which is this reference here, and assign to a, the parameter, the exact same reference, right? So a is also going to refer to the same list, okay? And b is going to be, let me see if I can, I'll choose red here. So y's in globals is this reference, right? And we're saying assign whatever y's is to be what the b parameter is in this frame. So b is also going to refer to that same list with 3 items in it, okay? And so now we've established our references, we've passed those in, and we're ready to jump into this function body. Right off the gates, we see that there's a variable named result set up with an initial value of 0. And on line 7, you see that we're declaring a variable named short, but we're not actually initializing this variable yet. We're just saying short is going to be a variable that will hold a reference to a list of integers, but we're not ready to assign it yet, because you'll notice that in this if-else statement, we're going to either assign it to a or b. We have more work to do to figure out what we're going to do with that variable, right? So on line 8, we test is the length of a. So the length of a is the number of items in a. So we follow this reference, and we see that there's 5 items in a. So the length of a is 5. And the length of b is 3. Is 5 greater than or equal to 3? That's true. So we're going to go into the then block and ignore this else block, right? And here we're saying take the length of a, which we know is 5, subtract the length of b, which we know is 3, So 5 minus 3 is going to be 2, and assign that to result. So result changes from 0 to 2. Okay? And here we're finally initializing the short variable. And here we're saying, take whatever B is. So we look in our current frame, and B is the reference to this list 0, 1, 2, or sorry, 1, 2, 3. And we're going to make short be that same reference, right? So short is now also going to be a reference to this list. Now we want to be very, very careful here. Something you never, ever, ever want to do on this line is something that looks like this, right? You're never going to draw an arrow back to somewhere on the stack. In some cases, it might work out, but there are cases where it definitely will not work out. What we're saying here is take whatever B is, and B is a reference or a pointer to this list. And so short is also going to be a reference or a pointer to that list. After this point forward, it's only just a coincidence that short and B point to the same list in the heap. All right? From here, we see we reach a while loop that looks pretty familiar. And we see that there's a variable named I being established. Let me switch back to blue. So our index or our counter variable is 0. And we're asking, or we're looping while I is less than the length of short. All right? So the length of short is the length of this list with 3 items in it. So while I is less than 3, 0 less than 3, that's true. So we go into the repeat block. And here we're asking if A of index I, so if I were to look this up, so A at index I is 1, right? So 1, is that not equal to B of index I? So B of index 0 is 1 as well. 1 not equal to 1 is false, right? So because that's false, we're not going to go into the then block. We're going to skip over it. And we're just going to increase our counter variable by 1, right? So now I is going to be 1. We've reached the end of the repeat block, so we go back up and we test again. Is I, which is now 1 less than 3, that's still true, right? So we loop again. And we ask I at index 1, or sorry, A at index 1, A at index I. A at index 1 is 3. 3 not equal to B of index 1, that's 2, right? So let me pause this really quickly because this is the one that we need to be careful of. So what we're seeing here is if A of index 1, which is our I value, not equal to B of index 1, right? And so I substituted I with our current value of I, which is 1. And so then we look up, what is A of index 1? A of index 1 is the number 3, integer 3. 3 not equal to B of index 1 is the number integer 2. 3 not equal to 2 is true, right? These are two numbers that aren't equal to one another. So we go into the then block and we increase our result by 1. So result is no longer 2, it's now going to be 3, right? And we've completed line 18. We go on to line 19 and we increment I one more time. So I is no longer 1, it's now 2. We go back up to the top of the list. Is 2 less than 3? That's still true. And once again, we test is A of index 2. That's the number 3, not equal to B of index 2. That's the number 3. No, they are equal to each other, so that's going to be false. So we're not going to do this then statement. We increase I one more time. I is 3. We go back up to the top of the loop. Is 3 less than 3? Nope, that's false. So we're done with our loop, and we reach this return statement. And what we're returning is result. Result is 3, so our return value is going to be 3. And where are we sending this 3 value back to? Well, we're sending it back to line 26, which was where the function call originated, and so our output is going to be 3. So we just traced through this in a very mechanical way, and before we take questions, I want to talk a little bit about the intuition of this function. So this function tells us the purpose of it is to count the number of differences between two lists. And if we look at the list that we gave it, well, we know that one list is 2 items longer than the other list, so there's 2 differences already. And if we looked at the first 3 items in each of the lists, we see that the second one was different, so that's 3 differences, and that's where we got the number 3 from, right? After questions, I want to talk about one variation of this that I'd like you to practice, but any questions on what we've seen up here so far? Got a question here, coming around with the mic, just one sec.
So when it says to declare a variable short that is a list, why are we not, what's the difference between what we did and like creating a new list that's exactly the same as YS? Why did we say that this new list is also like an arrow to YS?
Good question. So one of the things that's interesting about this is, and you all saw this in the most recent exercise when you're trying to compare two lists, and maybe they're not the same length as one another, so you've got to be careful so you don't ask for an index in one that doesn't actually exist in the other. And I'll come back to specifically this question here. In this while loop, we're trying to loop through the shortest of the two lists, right? Because that's where, if we go to index 3 of the second list, we're going to be out of bounds and we would have an error in our program. And so one of the places where references are kind of nice is we can say, hey, let's set up a variable that can just be another reference to some list we already have, rather than having to make a complete copy of it. So we didn't know at this point which of these two was the shortest. If you tried to implement the same function without using an extra variable here, you'd have needed to duplicate this while loop or set up some other variable in order to know like how many spaces to check, or in order to know that you needed to check only the first 3. Another way that I think will help make what's going on with this short reference a little bit more obvious is, and this is the exercise I would encourage you all to try on your own, imagine calling differences with y's as the first argument and x's as the second, right? And so in other words, if we swapped the arrows of A and B in differences, this function should still be able to compute the differences between them. And additionally, you could try it with y's and y's, right? And you would expect there to be 0 difference between two references to the exact same list. But to come back to this declaration question, at this point in the program, we didn't know what to assign it. We could have said is assigned the empty list here. But what that would have done is initially said, OK, short is this list of integers that's empty. And as soon as we got down to line, say, 10 or 13, what would have happened is, OK, nope, short no longer refers to that list. Now it refers to the list that we're intending for it to refer to. And we kind of set up a list in memory that has no purpose otherwise, and it's sort of wasted memory. It's admittedly a little bit nuanced, but the idea is we want this algorithm on lines 15 through 19 to work for whichever list is shorter. And we don't know when this function's called, whether A is going to be the shorter of the two lists or B is going to be the shorter of the two lists. So we set up a variable that's going to refer to the shortest of the two. Other questions? So again, the exercise that I think will be very valuable, I'll say it one more time, is imagine calling differences with, and I'm going to shorthand this, diffs with x's, and diffs with y's, x's, and convince yourself that you understand how these references ultimately work. Both of those are valid function calls. And you should kind of be able to expect what the result is in doing so. That's all we've got for today. Look for the next exercise and practice problems going up very soon.
Do that just because I'd be worried about confusing whoever's grading it, right? So I wouldn't do that just to save you trouble, right? Yeah. Perfect. No problem, man. No problem.
Your problem. I think that you can't just make individual scans. I can do more time on that, but I have to send preset stuff to it. Yeah, I just wouldn't say there's enough to do that. I don't think there is. You might be able to save them all to your parents if you have them in the single email separately. But yeah.
Some girl might email call told me that the other day. She's like, I see you on my For You feed.
Okay, I had like a 2. And then I had a Survivor one, which I was very excited about. My family talked about Survivor for like most of the years.
This is a question.
Yep.
Is there a way we can like figure out our grade, like, or without like actually calculating it ourselves, or no?
Unfortunately, that's the only good way.
Okay. Thank you.
You can write a program for it. It'll help you in the future.
Jordan, I have a situation where I actually use 2 computers. I know I shouldn't have, but basically my first computer is pushing to the backup where only this one can back it up. The one that I bring to class, I cannot back up on this one. So what would you say, like, what is the best thing I could do?
No, I'm okay.
If they're specific, okay.
Yeah, but they're like,
There's a problem.
yeah, they're like, it's best.
So I think so. The challenge is, yeah, you can get out of sync. So we've got a couple of options.
Yeah.
Is the one that you bring to class the one that has like most
I
of
would
the
highly
levels?
recommend going to tutoring.
So what we can
That's
do
Tuesday,
is
Wednesday,
we can
Thursday,
potentially
5 to
delete
7,
your
and you can literally get there
repository
at 5 and stay until
for your
7.
old one.
You can ask as many questions
And
as
you
you want.
can
I've had a lot of people
start a
come
new one, start
for like
pushing with
minimum.
the
I don't
one
think
you
I've had one
bring
that's
to
been
class.
shorter than
And
like 40
then
minutes.
On your
That's
old one,
a
you
great
can
time where you can ask
reclone the new
as many
stuff.
conceptual
You may
questions
want to send
kind of as you want.
whatever files you want
Office
from
hours
your
really
old
don't
one
have to
to your
do
new
just one question. Really,
just
if
to
you
get
come
that
on
all
like
going.
today,
in the
right?
future,
The day after a
the
deadline
way
day,
it winds up
probably gonna be
needing to
really
work
dead. You
is
can totally come to office hours
you
with
can have 2
conceptual
computers
questions
going,
as well.
but
tutoring
you
is
have to
really
be in
where
a
I
good
would
habit
point
of
you with
pushing
that. There's
from
also
one,
an
and then before
outreach
you do
team
anything
that
to
we
other,
have. So
pulling,
they help
and then
people
pushing from
who,
that one and then
like you,
pulling.
like just want
So
more help.
you
So
can't like
I
start
would
making commits on
reach
the
out
road,
to your.
and
Did
then
you ever get an
pushing-
email from like
yeah,
one TA
that's
being
what
like,
you
I'm your
do.
dedicated TA?
So yeah, so
Okay.
if you shoot me a message
not,
with your
I will
GitHub
actually
username, I can
give you the
delete your
outreach email,
repository
and you
that's
can
currently
send an
there.
email to them, and
And
Jasper's
then
in
you'll
charge
just
of
set
that,
up,
and they
you'll
will
just follow
help
the link to set up a
you,
course repository, and when you push
with
that,
support.
it'll be from your new computer. It'll just work.
Okay, and then I would have to move all the files I currently have backed up from GitHub onto something else, and then transfer it over.
Yeah, you can throw them all in the repository on your new computer.
Yeah, so this will be the email.
So like
COMP110
either
outreach
email a zip to yourself,
@unc.edu.
move the files in, or something.
Just send them a note,
Okay,
kind
and
of
then just push it
what you got going on.
Yeah.
Cool.
And they can help you and point you to good resources. And yeah, I would just say tutoring is a big thing, office hours is a big thing. And yeah, reach out to them with anything else. If you still want to chat with Chris, you totally can.
Yeah,
but
if you email
we
me
want to
the
help
zip,
you guys
we can
do
upload
well.
it for you. So if you email your zip
Okay.
to COMP110.002
I like turned in that project yesterday.
dash
because
actually, I think I
didn't
might
do
be able
it,
to.
and
Let
I
me just
still, like,
finish this out.
Because the auto grade was like, I'm not even gonna say the grade out loud. Though.
That's okay. Okay.
Let me see if I can actually.
Yeah, no worries. Sounds good. Do you have a question?
Yeah, I'm a freshman and I'm intending on majoring in comp sci.
Awesome.
Is there like, do I need to